Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and I'll be the first to admit that today's project is a little bit outside my comfort zone. Let me bring the camera in a little closer and show you what I'm talking about. Thanksgiving Day, our family got together at my great niece and great nephew's home. They were gracious enough to host the family for Thanksgiving. But shortly after getting there, my nephew uh, said he had a piece that he would like for me to look at to see if I could do some work for him on it. I've done a few other little projects out here in the Tin Barn for him, but this one's a little bit more involved than I'm used to. But we're going to handle it. We're going to take care of it. This is an intake manifold to an engine he's building that will go in a C60 flatbed truck. He wants to install this oil fill tube. Evidently, the engine that's come off of had the oil fill in the valve covers. But this one, the instructions that came with this say this oil fill tube requires a 1.25-inch hole to fit properly. Only manifolds with this hole pre-drilled or a raised boss intended to be drilled should be used. Well, this manifold has the raised boss but doesn't have the pre-drilled holes, and that's what he wants me to do today. And again, a little bit out of my comfort zone, but we're going to do it. Now, he brought this manifold up on the Saturday after Thanksgiving. I told him, I will get on it the following week, which this is the following week now. And then on Sunday morning, he sent me a text and said, hold off on this one, that he had another manifold, I guess he had ordered, had come in, and he wanted to do it, the work done to it instead of this one. Now, that other one's already sitting on the mill. I was going to do a little mock-up yesterday on the setup, and I got it to the point where I didn't want to take it back down. So I'll show you what we're going to do on this manifold, but the one, you'll see the difference when we get over to the mill. The one that's on the mill is a polished aluminum, where this is just still the cast aluminum. But this boss right here, there's a couple of things we got to keep in mind with the setup. It is not on the same plane in either what we'll call the X or the Y and the X. It's not on the same plane as that. So we've got to tilt it up to get it level on this plane. And then we've got to adjust the mill head to get it on this plane. Now, this is simply a little piece that I turned on the lathe to help me get that. There's no surface in here to indicate on. Even on the polished one, it's still a cast surface. And there's not enough distance in there to really try to mic it in to begin with, or use an indicator on. So I turned this piece on the lathe. This will fit up in the drill chuck on the lathe. And I'm going to try to position this and the mill head such that this surface right here turns up flat, sets flat on this boss down here. So let's turn over to the mill now, and I'll show you what I've got so far. All right, over on the mill table now, as you can see, this is the polished aluminum intake. It's hard, I know it's hard for you to tell in the video, but I think I've pretty much got it level on this plane, this surface right here. The way I did that, if you notice back here, this is not setting flat. This angle is not the same as the angle on the manifold, but I've got a couple T-nuts in there, and the bolts down, and kind of played around with it a little bit by setting a flat piece on there and a level on the flat piece. And I think I've got it reasonably close in this direction. Now, it's way off in the other direction. So the way we're going to compensate from that is I'm going to tilt the mill head. But before I get to that point, I wanted to try to get our hole as close in the center as this boss as possible. It's not even flat on the bottom under here. So it's going to be kind of a weird drilling. But the way hope I've located the center as good as possible is I took another little piece of round stock and just eyed this, just looked at it until I felt like I had this piece of stock. This was again in my scrap bin or small piece bin, and it already had a hole drilled through it. I found a transfer punch that fit that hole, and just by eye lined this piece up as close as I could to what I felt like was center, tapped this, and got a little witness mark right here. Now to get it level on this plane, as I said, I've got this couple bolts in the T-nuts held as close to that plane as possible. And then on the back side right here, I'll put in a little picture and show you, but I wedged in a piece of flat steel in there. So this is plenty sturdy in that direction, pushing down on it as I will be drilling and boring. It's still loose in that direction, which pulling a drill out might raise it back up. But I want to take, once I get everything lined up, I'm going to put a toe clamp over here and clamp this down. And what I'm going to do, as I said, I'm going to loosen the locks on the mill head, and I'm actually going to tilt the mill head with this mounted in the chuck, of course. I'm going to tilt the head until this piece is set and flat. I may have to tilt back and forth, may have to adjust that a little bit as well, but that's the only way this amateur hobbyist, the only way in my mind I could come up with getting this as close to being on the same plane as this non-machine surface. So again, off camera, I'm going to tilt this, and I'll bring you back when we're ready to start drilling and boring our hole. Okay, I wound up having to break down that setup of this that I had to begin with. I had it too close to this end, and after tilting the head, I didn't have enough travel to get everything lined up. But I simply loosened these bolts back here, moved it down about 4 inches. Now, to determine what angle I needed to tilt the head, or at least get it close, I took my angle cube, zeroed it out, setting on the mill table, which of course is perpendicular or in line with the spindle, then set it on that plane, and it showed me 16 degrees. So what I did was tilt the head 16 degrees. Here's a quick image of looking at the mill from the front to show you what 16 degrees looks like on the mill head. And then over here on the side is the actual protractor to show the 16 degree mark. Now of course I'll have to trim the head back in after we finish this project. Now to get lined up on that little hole down here, I simply used one of my pointers that I ground at some point in time, put that in the drill chuck, and lined up. Now we're going to lock the table down in that position. Then replace the pointer. Remember this piece I said that I got out of my small material bin, turned it to go up into chuck. And my intention was to play with the tilt in both directions if I needed to get this setting flat. But folks, I can't get it any closer than that. Let me zoom you in. Here's a little witness mark that we centered up on. And that's setting just as flat. There's a little chamfer on it, so if it looks like this edge is up a little bit, that's what that is a little chamfer all the way around it. But that's as much perpendicular with that as I think I can get it. Now what I want to do, I'm going to see if I can get a toe clamp mounted over here that will not interfere with this. Alright, I got a toe clamp on now, and I just snugged that down. I don't want to put a lot of pressure on this outside edge, take a chance of breaking the ears off back here. The only problem with that toe clamp, it's going to kind of get in the way of you guys seeing what's going on. But I'm going to start with a smaller drill bit and work my way up until we get to the point where we'll take the drill bit out and use the boring head. So let me see if I can get the camera set up in a little better position where maybe you guys can see what's going on. Before I move the camera around, one more thing I'm going to show you. We got water intakes here. We got, I believe one of these is for the water temperature sensor. Not sure what the other one may be, but both of these ports right here open up where the thermostat goes. But we got the carburetor opening up here as well. Looks like we may have an oil pressure sensor. No, that would be down on the block. I'm not sure what this is, but anyhow, all the openings up here at the top, I'm going to mask off to keep from getting any chips falling inside the intake. Now, this is open, of course, through the bottom, so anything I drill here, chips will come through the bottom. Okay, I've got you guys back behind the mill now. So hopefully you can see what's going on. And I just realized that as I raise and lower the head for various tool lengths, I'm going to have to adjust the position on the x-axis of the table as well. Y-axis should be fine. All right, let's start with this 1/4 inch bit to begin with. All right, everything held steady for that one. And I'm going to do several steps here just to keep from putting a whole lot of pressure on it. We'll go up to a 25/64 now, a little larger than a 3/8. And I'm going to go ahead and slow the machine down a little bit now. I think I'll go on up this time maybe to a 9/16, and then we'll go a 15/16 before I put the boring head in. So this is a 9/16. See if it'll go in. Yep, it'll go without moving the head. A little bit of WD-40 helps keeping the chip from aluminum chip from bonding to the tool. And this is a 15/16 now. It just looked like it might be a little sharper than the 1 inch. All right, so we're gonna slow down even more. All right, so far so good. Now what I've got to do is put the boring head in, and I'm gonna have to line that up on center as well. That's gonna take a little bit of finagling, but I'll line it up with the hole. I'll bring you back when I got that figured out. Okay, I guess I lucked out. When I took the drill chuck out and put the boring head in, the boring bar that I had mounted in the head wouldn't reach all the way through it, but I had a longer boring bar, so I'm able to do this setup without having to move the height, which, as we saw earlier, would have lost center on this. So I about got it touched off now. I'm going to advance a little bit. And you folks have got even a better view than I've got. All right, I've got the boring head on a 0 now. I'm going to make this pass. Now I've got the DRO zeroed out now, so if I move this table down to get a measurement there, I should be able to come back to the same position. I'm going to do that. I'm going to move down, take a measurement, then I'm going to advance on the dial on my boring head and be sure I know how to read the dial. I think this dial is, in other words, if I run up 20 thousandths on the dial, I'm pretty sure that's 40 thousandths on the diameter. But I'm going to double check that, and then I'll bring you guys back as I'm boring all along, and we get to the point we're going to make a couple of test fits. And by the way, I'll be doing test fits with another piece of material that I got out of my small pieces bin. That tube obviously is too long to go in here with it mounted here. Plus the tube is meant to be driven in. It says drill a 1.25 hole, but the tube itself is about 5 to 6 thousandths larger than that, so that it has a tight fit when it's driven in. But this is 1.25 inches, so we'll be using this as our test. I'll bring you back again as we get progress through this. .207, so we got a little less than 50 thousandths to go. 50 thousandths would be 25 here. I'm going to sneak up on that. I'm only going to take about 10 thousandths on the dial. That should be 20 on the diameter. Getting a little close to my edge over here, a little closer there than I am right here, but it's still plenty thick under the bottom. I don't see any chance of it breaking out. I'm just going to simply creep up on this a little bit at a time. All right, that's the 1.25 just barely sneaking in there. I'm going to make one more pass without advancing anything, just to smooth that up just a little bit. Tell you what, I think I'm going to speed it up a bit too. I was going 320 RPMs. I'm going to go up to about 600 RPMs now. All right, I'm going to leave this set up just like it is. I think we're to the dimension now, but this tube has two graduations on it. The 1.250 was for this lower one. It's got another graduation up here. I've not measured it yet, but I'm going to leave it set up and see if we'll set that in there. See if he thinks it's going to be too high. If it's too high, we'll bore out a little bit more for this one. So I'll bring you back whenever we're ready to do more work on it, or when we say it's finished. All right, one more thing before we wait for him to get here. I moved this out on the y-axis and the x-axis so that the tool cleared the toe clamp. I just wanted to show you, again, this is the piece of this first step. Even though my 1.25 piece is a little bit loose in there after I made that cleanup pass, the tube will still have to be driven in. Uh, I'm sure he'll put some sealant around it, just just to be sure, or just try to prevent any uh, oil leaking up, splashing up through that. But it will take a drive-in now to get this seated. So, okay, my nephew actually lives right up the road from me. I sent him a message and with a picture similar to what you're seeing right here, and told him I'd like for him to come by and look at it before I broke down the setup. It turns out he's working from home today. He said, I'll be there in 10 minutes. And sure enough, he was. He took a look at it. He was tickled to death with it. So let's do a quick breakdown of this setup. Again, the toe clamp was just to keep it from rearing up if the drill bit got hung in it. Don't think there's much chance of the boring bar getting hung in it. But we'll take that down. And then the only thing else that was holding it was the bolts in the back. Okay, as it turns out, I decided I would put my angle cube on here when I had this set up. Remember we talked about the angle that I had to tilt the head was 16 degrees. Well, the angle on this axis turned out to be 25 degrees to get this set up on that plane. And again, as I said before, even though this is a polished surface, it's not a machine surface. So you won't necessarily be able to put an indicator on that. But keep in mind, this is for an oil fill tube, and that tube, as the intake is setting, that tube will drive in once this is positioned down. As I said, he seemed very pleased with it, and I don't know that I mentioned it up front, but the engine this is going on is a small block Chevrolet, and it's in a 1966 C60 flatbed truck. Not sure exactly what the size engine is on this, but hopefully if you're watching this video, if you came to this video looking information on drilling or boring the hole for that, it's not something you could do with a regular drill press unless you've got a boring head that will fit it and a pretty elaborate drill press. But it turned out to be a rather simple task on a small milling machine. This is a 7-inch by 27-inch benchtop milling machine. It's Precision Matthews PM 727. But whatever reason you came and watched this video, I hope you've enjoyed it. Take care, and I'll see you on the next one.